There's a positive real number x not equal to 1 over 20 or 1 over 2 such that log base 20x of 22x is equal to log base 2x of 202x. The value log base 20x of 22x can be written as log base 10 of m over n, where m and n are relatively prime positive integers. Find m plus n. Okay, so what we're going to do is we are going to set both of these things that were given, log base 20x of 22x, log base 2x of 202x. We're going to set them both equal to k for some number k. And we can realize that whatever the problem was saying before, this problem statement just says find k, because you ultimately what you're going to want to do is you're going to want to find the value log base 20x of 22x, which we just defined as k. So if you can find k, we are basically done. Okay, so now that we've got our goal specified, how are we going to get to that goal? Well, we have this equation, and that's really all we're given. So we're going to need to use this equation somehow in order to be able to, really work with k, and as well as this x, because there exists some x that's not 1 over 20 or 1 over 2 such that this thing works, and this implies that there's a unique x and a unique k. So what are we going to do? We're going to try to solve for x and k. We have log base 20x of 22x is equal to k log base 2x of 202x is equal to k as well. And what we're going to do is we're going to rewrite this. We're going to rewrite each of these in exponential form. And what do I mean by exponential form? I just mean that if you have this logarithm, we can write it as log base 20x, 22x is equal to k. We can write this as 20x to the power of k is equal to 22x, 22k. No, 22x, excuse me. 20x to the power of k is 22x, because log base 20x of 22x is equal to k. Okay, that's cool, but we can do the same thing for this next one. You have 2x to the power of k is equal to 202x. So that's also really nice, but what are we going to do now? Well, we have some equations in terms of x and k, but it just doesn't seem like it's going anywhere. So, well, first of all, what I'm going to do is I'm going to expand this one out by exponent properties. This is 20 to the power of k times x to the power of k is equal to 22x. And guess what? I am just going to divide both sides by x to get 20 to the k times x to the k minus 1 is equal to 22. And expanding this one out gives 2 to the k times x to the k is equal to 202x. But we can divide both sides by x to get x to the k minus 1 on the left-hand side. We have 20 to the k x to the k minus 1 is equal to 22. 2 to the k x to the k minus 1 is equal to 202. And we can realize that now we have a way to get rid of the x's. We can divide this equation by this equation, and then all of the x's will magically go away. So you have, what do we have? We have 20 to the k x to the k minus 1 over 2 to the k x to the k minus 1 is equal to 22 over 202. Really convenient, because x to the k minus 1 cancel out with x to the k minus 1. Let's get rid of both of those. 20 to the k over 2 to the k. This is equal to 20 over 2 to the power of k, which is equal to 10 to the power of k. And that's equal to 22 over 202, which is equal to 11 over 101. And so how do you find k? Well, you can express this thing in logarithmic form. Just do the opposite of what we did before. We have 10 to the power of k is equal to 11 over 101. Therefore, log base 10 of 11 over 101 is equal to k. So since we wanted to find the value of k, and k is equal to log base 10 of m over n, you have m over n is equal to 11 over 101. 11 and 101 are relatively prime. Add 11 and 101, you get 112, and that is your final answer. So we are done. Thanks for watching, and I will see you next time.